All right, so we're going to be starting chapter 10 right now. It's all about circles. So 10.1, here is our essential question. This is the thing that we got to be thinking about throughout the lesson. What are the definitions of the lines and the segments that intersect a circle? So there's multiple, and we're going to go through them today. So first thing, just look at this picture right here. We have different types of line segments and different types of lines that intersect a circle. So it says work with a partner here, but just look at these chords and later on you'll actually see the definitions. But notice that a chord intersects the circle. It's a segment inside the circle, and it intersects the circle at two places. Okay, that's a chord. Then a secant is like a chord, but the secant line actually goes through the circle and continues on forever. Okay, so that's what a secant line is. Tangent lines are special. We're going to do a lot more tangent lines. But notice a tangent line touches the circle at one spot and it is perpendicular to the diameter. Okay, so a diameter, that's first a radius. A radius goes from the center of the circle to the outside of the circle, and it's just a little segment. And then a diameter is a segment that goes from one end of the circle all the way to the other end of the circle, and it must pass through the center. Okay, diameter and radius pass through the center of the circle. Now, there's lots of different relationships with these segments and these lines. Okay, and we're going to be talking about those. We'll just move on. So here, right here, the core concept, this right here, or these are the official definitions. Okay, and we have different examples. You might want to pause right now just so that you can remember these, write these down. These are your notes. Okay, moving on. So this example, tell whether it's an array, the line array or segment is best described as radius, chord, diameter, secant, or tangent. So AC, let's just talk about AC real quick. Notice it goes from the center to the edge, so that's a radius. Okay. A to B. It goes from one side of the circle to the other, and it crosses through the middle, so that's going to be a diameter. D to E crosses or touches the circle at one point, and it's perpendicular to that diameter, so that has to be a tangent. And then AE, so A to E here, since it is a line, not a segment, and it goes through parts of the circle, that would be a secant line. Okay. If it wasn't a line, if it didn't have those little arrows on it and it just stopped A to G, that would be a chord. So there's some examples. You can go through those examples there. Okay. Coplanar circles and common tangents. So in a plane, two circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. Okay, so these are the circles in red right here. These are tangent circles. They intersect at 1 point. All right. Coplanar circles that have common center are called concentric circles. So this in green over here, these are concentric circles because they share the center. A line or segment that is tangent to two coplanar circles is called a common tangent. Notice in the red you have two different common tangents. And a common internal tangent suggests the segments that join the centers of the two circles. A common external tangent does not intersect the segment that joins the center of the two circles. Okay, so we have these three different types of circles. 2 points of intersection, 1 point of intersection, and no points of intersection. So, A, B, and C. Tell how many common tangents the circles have and draw them. Use blue to indicate common external tangents and red to indicate common internal tangents. So, if we look at this, part A right here, how many common tangents are there? There's no common tangents. In part B, there's one tangent, and it goes right here between the two. I'm not using red, but so they have a common tangent right there. And then part C, there's no common tangent as well because there's intersection. Okay, moving on. Okay, theorems. This is where we want to spend a little bit more time. Theorems. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So this is what we talked about earlier. This is a tangent line if this is 90 degrees. Then we have external tangents. Tangent segments from a common external point are congruent. So this point right here, S, and this ray goes from S, goes through T, and goes over that way. That's a tangent line, but the distance from S to T is the same distance as S to R because both of these go from the same point. Okay, they both leave from S. So, is ST tangent to circle P? In order to solve this, we've got to prove that this right here is 90 degrees. So now that we know what we need to do, remember that 90 degrees is a right triangle. So we have leg, leg, hypotenuse. So we do 12 squared plus 35 squared equals 37 squared. Square root everything. So 12 squared plus 35 squared. And then square root of 37 squared. Okay. If it's the same thing, we have a right triangle. And in fact, we don't even have to do this part. I jumped the gun on that. We can just prove if this and this are equivalent to each other, then we are golden. So I'm going to try to pull up the calculator here real quick. Well, I'll just use this one and you'll. So 12 squared is equal to 144 plus 35 squared is equal to 1225. And does that equal 37 squared, which is 1369? Okay, so 144 plus 1225 is 1369, and 1369 equals itself. So we can conclude now, since this is true, that the angle at T is 90 degrees. Therefore, S to T is a tangent. Okay, because S to T touches the circle at T and creates a 90 degree angle with the radius P to T. Okay. All right. There's some more of that. This allows you to figure out R. We can work this one together. Find the radius. So we're told that A to B is a point of tangent C. So we need to find this radius right here. So we got to set up our Pythagorean theorem. If we have 80 squared plus R squared, that has to equal 50 plus R, because that's going to be our hypotenuse, squared. Now, to go from here, we just got to do some quick calculations, okay? If we remember, that's 50 plus R times 50 plus R. This is where we want to FOIL. 50 times 50.
Teachers, if you have